We are now starting the Unit 4 exam review, which is on trigonometry. We're going to start with SOHCAHTOA. So we might want to write it out on the top to remind ourselves what it is for. We use it to solve right triangles only. So here's an example where SOHCAHTOA can be used. Calculate the length of QR. I'm going to call that x to the nearest tenth of a centimeter. If we take a look at the angle that's a given, so we are given the angle of 52 degrees, and we are also given the side of 5 centimeters, which is opposite across from 52 degrees. And we are looking for x, which is adjacent, beside 52 degrees. So we are going to be using tan, TOA, because we have opposite and adjacent that are in play. The tan of the angle 52 degrees is equal to the opposite 5 over the adjacent x. By cross multiplying, the x multiplies up to the other side, and the tan 52 divides down. And when we plug it into our calculators, we get 3.9 centimeters. With side lengths, if you remember, we round to 1 decimal. And that's the answer. Question 2, application. A sign above a store. So let's draw the scenario. Is 9 meters above the ground. Can the sign be painted using a 10-meter ladder? Ladders are put diagonally against the wall. For safety reasons, the angle between the ladder and the ground should be between 60 and 78 degrees. So we have 9 meters above the ground. We have a 10-meter ladder. And the question is asking about the angle between the ladder and the ground, which would be here. And we need to know this angle. And if it lies between these two numbers, then we are safe. So the angle in question, we can use the capital letter A, any letter you want. So what are we given in reference to angle A? We are given the opposite of 9. We are given 10, which is the hypotenuse. And we need angle A. Our choices are to use sine, cos, or tan, SOHCAHTOA. We have opposite and hypotenuse, therefore we're going to use sine. The sine of angle A equals opposite 9 over hypotenuse 10. And when we are solving for the angle A, we have to do the inverse. I'm going to write the step to the calculator here. You're going to want to press the shift or second function button. And when you calculate angle A, you get rounded 42 degrees. Angles we round to the nearest degree. Question 3. When playing a local golf course, the designers wanted to include 2 water hazards near one of the holes. The initial planned measurements are shown. Find the remaining lengths and sides. It is a non-right triangle. Therefore, we cannot use SOHCAHTOA. So our choices are sine law or cosine law. We are going to use the sine law in this question because we are given a pair of opposite angle and side, and we have another side length 45, and we can use it to find the opposite angle here, which I will call x. So the first step would be to do that. We have the sine of 70 degrees over 80 meters equals the sine of x over 45. We can cross multiply the 45 up on the left and the 80 up on the right. We can divide down that 80. You can skip steps if you are used to it already. And then we need to inverse the sine, and when we inverse the sine, we get 32 degrees rounded as our missing angle here. The second step that we can do is to find the third angle by doing 180 minus 70 minus 32, which gives us an angle of 78 degrees, which is over here. And the third step would be to do the sine law again to find, I'll call that side y. The sine of 78 degrees over y equals the sine of 70 degrees over 80. I'm going to use the given angles and sides because this 32 degrees here is rounded. If we cross multiply, we get 80 sine 78 equals y sine 70, and y equals 80 sine 78 divided by the sine of 70, and we get a side length of 83. We round to 1 decimal, 0.3 meters. We now have all three sides and all three angles. Two trees, question 4, form a triangle with a boulder in the park. We form a triangle, 1, 2, 3, with a boulder in the park. So here's a tree, and here's a tree. One tree is 17 meters away from the boulder. The other is 21. The angle between the boulder to each of the trees is, one angle is 33 degrees. How far apart are the trees? We are using the cosine law here because we're dealing with three sides and one angle. Go back in your notes to refresh when to use which law. Cosine law is similar to the Pythagorean theorem with a subtraction of 2 times the two sides times the cos of the contained angle. When we simplify and solve, we get an x value of 11.5 meters. Because this is a word problem, we want to answer therefore. The angle is, and you can write a nicer sentence than me. Question 5. The posts of a hockey goal. We had this question in homework and perhaps on the test. Are 2 meters apart. A player tries to score a goal by shooting the puck from a point 5.2 meters from one post and 6.3 from the other. Within what angle, I'll call that angle A, must the shooter shoot the puck? We are using the cosine law again for the same reasons as before. 3 sides given and 1 angle missing. Remember that the side length that starts the formula is opposite of the angle that ends the formula. If I rearrange this, and again there are different versions of this law that you used, you get something like this. And when we solve for A, doing all of the algebra, we get 17 degrees. Again, it's a word problem, so therefore, the player shoots within an angle of 17 degrees. Question 6, we are not going to review for the exam, and therefore, you can now start your booklet, examples, and questions for the summative on Unit 4.